Today's lecture will cover recorded detail. Some synonyms of recorded detail include definition, sharpness, resolution, and spatial resolution when working with digital imaging. The definition is the degree of geometric sharpness or accuracy of an image. Detail is limited by the ability of the human eye. The resolution test tool is utilized to determine measurement of recorded detail. The unit of resolution is a line pair per millimeter. The more line pairs per millimeter that are visible by the human eye, the greater the resolution. Another form of measurement used is bony trabeculae. These are bony markings that are on each bone and are specific to that particular bone. It looks like lines or scratches on the bone. Remember, the radiologists do not have the resolution test tool on patient images in order to evaluate detail. All radiographic images have less detail than the object being imaged. It is important to optimize the detail that is captured in that image. Spatial resolution is the ability of an imaging system to accurately display objects in 2 dimensions. The body is a 3-dimensional object with planes of coronal, sagittal, and axial. The radiographic images are attempting to demonstrate a 3-dimensional structure in 2 dimensions. Point spread function, also known as line spread function, and edge spread function all express the boundaries of the image. The umbra is the distinctly sharp area of the image. The penumbra is the imperfect shadow surrounding the umbra. There are several factors that affect detail, including focal spot size, SID, OID, the image receptor, and motion, whether it's involuntary or voluntary. All of these factors are under the control of the radiographer, except for involuntary motion. The factors that affect the visibility of detail are density and contrast. If an image is over or underexposed, detail cannot be visualized accurately. For example, if there's quantum model or if the image is too dark. If the scale of contrast is inappropriate for a chosen exam, detail cannot be visualized accurately. There is an inverse relationship between focal spot size and detail. For example, as focal spot size decreases, detail increases. There is a direct relationship between SID and detail. As SID increases, detail increases. There is an inverse relationship between OID and detail. As OID increases, detail decreases. There is an inverse relationship between relative speed and detail. As relative speed increases, detail decreases. There is a direct relationship between motion and detail. As motion increases, detail decreases. In order to optimize detail, we need to eliminate motion, reduce OID as much as possible, use the smallest focal spot, use lower relative speed image receptor, and increase SID. We can calculate the amount of penumbra by using the Penumbra Formula, which is penumbra equals focal spot size times OID divided by SOD. SOD is the source to object distance, which is achieved by subtracting the OID from the SID. Some methods to reduce motion include communication, if you provide clear instruction and breathing instructions, utilize immobilization devices when necessary, such as sponges, tape, or a pigostat, and reduce the length of exposure, which can occur by increasing MA. In summary, there are 2 photographic properties, density and contrast, which affect the visibility of detail. There are 2 geometric properties, which are detail and distortion. These are the 4 image quality factors.